So last video you guys learnt about few terms. So in this, first one is magnetic induction. Alright. See, before we start with the definition, let me explain what it is. Alright. See, you have some external magnetic field and let's say you place some ferromagnetic substance in the external magnetic field. Okay. Now consider an iron piece. See here what happens, because of the external field, even the ferromagnetic substance will gain some of its magnetic field and it will also start acting like a magnet, correct? Right. So you will have a magnetic field from that particular ferromagnetic substance. See, something like this, right? Now, very important point what you guys have to notice is, see, near the pole of the ferromagnetic substance, what's happening? The field is getting denser and denser, correct? Meaning more field is there near the pole. But at the midpoint of the magnet, there two fields are in the opposite direction, so they will cancel out each other, right? So what happens? The net magnetic field, okay, net magnetic field will be something like this, correct? Because if you look at the figure, the magnetic fields are denser near the poles and it's very less near the center, correct? So this is basically inducing magnetic field, right? So now let's start with the definition. It says the magnetic induction is defined as the number of magnetic lines of induction that is inside the material crossing per unit area normally through the magnetic substance. So you have a magnetic substance, how much of the magnetic field lines it goes inside the material. Okay, so you have B is equal to mu naught H plus mu naught into I. Mu naught H is basically B naught. Remember the previous video you guys did about magnetic intensity, that one, plus mu naught into I is the intensity of magnetization. So you have B is equal to mu naught into H plus I. Alright. So for this, Tesla becomes the SI unit. Alright. So Tesla is the SI unit. So let's move on to the next one. The next one is magnetic susceptibility. Alright. Now magnetic susceptibility, it is the ratio of intensity of magnetization to magnetic intensity. Let me repeat it again. It is the ratio of intensity of magnetization to magnetic intensity. Alright. So it is denoted by Xi. So you have Xi is equal to I divided by H. Alright. Now since both I and H, both of them have the same unit, that is ampere per meter, this becomes a unitless quantity. Alright. See, susceptibility is very simple. Like how easily you can make the material to be a magnet. That is what we call a susceptibility. Okay. How easily you can magnetize a substance, like ferromagnetic substance, easily you can make it. Okay. Or a non-magnetic substance, it's very hard. That's it. So that measure is what we call a susceptibility. Alright. So the next one is magnetic permeability. So magnetic permeability of a magnetic substance is defined as the ratio of magnetic induction to the magnetic intensity. Alright, let me repeat it again. It is defined as the ratio of magnetic induction to the magnetic intensity. Okay, so you have mu is equal to B divided by H. Alright, now the SI unit becomes Tesla meter per ampere. Okay, now in layman terms, if you have to know what it is, it's nothing but how much of magnetic field lines a material can store in it. Okay, like if you have soft iron, it can store more. So what we have, it has high permeability. Alright, if it is vacuum, it's very less because it cannot store anything. Alright, so that measure is what we call as permeability. Alright, so see, till now whatever you guys have learned was first was magnetic intensity, right? Then you learnt about intensity of magnetization. Then you learnt about magnetic flux, then magnetic induction, and then magnetic susceptibility and magnetic permeability, correct? So these terms are very important. So you guys have to remember the definition and the SI unit and the formula. All right. So see, what you guys see is next you'll see a table on this. Go ahead, pause the video and learn the SI unit and definition for all of them.